Hi everyone, my name is Samantha and I'm the lead of R&D department for AI Club. And today we're doing a really simple project about how do we use LLM to analyze and diagnose X-ray images of so that if you have any bone fractures, your LLM can directly predict it. So in a more traditional approach is that if you wanted to have a chatbot that diagnose your bone fracture, what would usually people do is to first train a machine learning model, or more specifically an image detection model, to detect where does the bone fracture or where does the injury happen, and then we will pass the detected output from your machine learning to the LLM and ask the LLM to explain what happens to the X-ray images. And some of them, if they wanted to have a more reliable output from the LLM, they will also incorporate RAG, which means that you give the LLM some medical knowledge to refer. But in this case, we are going very simple by using a medical specific LLM, which means that this LLM is already trained with medical knowledge. So you yourself don't have to implement whatever RAG infrastructure, or you don't have to train your own image detection model. And here's what you will have at the end of the workshop. So it's a really simple chatbot user interface. So you can upload your own X-ray images and have it to run the initial diagnosis scan. And if you don't understand the output of the LLM, you can also ask follow-up question. Yep. So today we'll be using Google Colab Notebook specifically. I have already shared the link to this Notion page in the Microsoft Teams meeting, so it's here. Anyone didn't receive or didn't see the link? Discord. Wait. Can. Owen, can you send the link into Discord? Thank you. Okay, so today we'll be using the Colab Notebook attached here. So here's your first task. Click into this Google Colab Notebook. So to cross-check, this notebook is called Kickstart LLM, and this is my version, my copy of this notebook. You can edit, but you cannot save whatever output or whatever progress you have. So in order to make your own version of the notebook, you need to click File and save a copy in Drive to make your own copy in your own Google Drive. Because whatever changes you make in my copy, it will not reflect, and next time when you reopen this notebook, it will not show the changes you have made. Once you see your copy, which is usually it's called copy of Kickstart MLM, try to run all the code until this model equals to MLM. Run until this step. So the reason to run this code before I explain anything is that this model is 7B. It takes some time to load into your Colab notebook. And one reminder is that please run your notebook, run your session with T4 runtime. So if you click this arrow here and you realize that your hosted runtime is not as same as mine, it's not T4, what you can do is to click the change runtime and change to T4 GPU. Some of your default accelerated CPU, but that is not really sufficient in our case because we are loading MLM. So it will be better if you can switch to this T4 GPU. Once you have reached till this step, until running the code chunk MLM, run until here, Then you can react my message in Teams. Have everyone reached to the step run this chunk? Yep. Okay. So I'll move on. So actually, as you can see, this is quite a simple project with like very few chunks of code. So basically, if you run everything, it will work. But I'm not a good person. That's why if you notice, if after you load the model correctly, you will notice that you can't run the remaining code without any error because I have included a lot of placeholder here, and going through the session, we will fill up the placeholder together to run the code properly. If you run the code now, it will show error. So yeah, I will now proceed to a bit explanation on the concept of MLM. So, by the way, MLM stands for Multimodal Large Language Model. So instead of just handling the text, now MLM can do more than LM in the sense that it can also processes like the multimedia elements, especially image and also video. So what is the difference is that you can move on to the second page, which is LM process explanation. So there is a few extra steps if you wanted to code an LLM. Is that number one is called encoding. So your MLM cannot really understand pixels in the images, and that's why you have to convert it into another format, which is through a process called encoding. And also so that just to remind all of you, there is actually two kinds of encoding in this code. The first kind of encoding is what I mentioned, is to encode your image into what we call visual token before passing to the MLM to process. And the second is to encode into base64 string, because later we will connect your MLM chat history to a Firebase database so that your chatbot will still remember whatever images you pass in or whatever question you have asked previously. And your Firebase can't really store images. That's why you have to change it to the format of base64 string. So here's the code to transfer or to convert an image into a base64 string. So first thing first, we will initiate in-memory buffer, which using the bytes.io function, and we will convert the image you have into RGB format. Because as you guys know, X-ray is actually black and white only. So sometimes your image could be stored in just black and white, and that's why we need to convert into RGB first. Because mostly the MLM will handle images in RGB. So after converting into RGB, we will also save it into our buffer in as a JPG image, and later we will encode it, then decode it into the format of UTF-8. So the purpose of this image is to, given like a normal image like JPG or JPG, it will encode into base64 string that will look like this. And if you notice in our code, which is the Kickstart LM, there is actually two placeholder in your base64 image encode. So you can fill in with the proper code, which is first convert into RGB format for the typical image, and second is to save your image into the format of JPG after encoding. And also, since we are encoding the image into a string before storing into your Firebase, so which means when you are retrieving your image from the Firebase to display the image, you also have to decode it into a normal image. So we have also another function called base64 image decode. You can't really run the code currently because your notebook is still loading the model, but we will run the code together later. So some might also question that because I just now I mentioned there's two different encoding in this notebook. One is to encode into Firebase and the other is encode to the model. So in case you are wondering, your MLM preprocessor will handle the encoding itself. So there's no specific code you have to write to encode your image before passing into the MLM. These two functions, the encode and decode, is just for your storing purposes in Firebase. Okay, so moving on from encoding, we will also take a look into what is called chat template. So as mentioned previously, your MLM model handles a little bit more complexity, which it has to handle image, text, and also videos. So we need to structure your input properly so that your model know which one is the input that they should handle and which are the instructions they should follow. And since we are using a model from Q1 in this case, so we are using a chat template called Chat Markdown Language ChatNL, which you will structure your message, which is your input to the model, in a list with dictionaries. So for each dictionary, it's like one of your input. And within each dictionary, there's actually two elements. First is row, and the second is content, which is maybe your question or the response of your model. And for rows, there's actually three types of rows for MLM. The first one is system. So system row is actually your general instruction you pass to the model. In this case, since we want the model to analyze X-ray images. So our general instruction that is you are a senior orthopedic radiologist and we tell them like in this specific use case what the model has to achieve. For example, it has to detect fractures, provide bounding boxes coordinate, which is to label the fractures position. And second, you have to provide a summary. Third is to write a detailed clinical report. So this is the general instruction that every time you input, you ask some new question, this will always be the general instruction that the model will have in mind when processing your questions. So the first row is system. Second row is called user, which is your input to the model. And the third row is called assistant, which is the model responses. So also moving into the code in your collab, under the prepare context function, you will see that there's a placeholder here in terms of the row. So here we can enter system because it's the general instruction to the model, which is you are a senior orthopedic radiologist. Okay, so let's dive down a little bit deeper to role specifically for user. So that in this case, there's actually two different messages or two different inputs we want to pass to the model. So here in the content part, we will also have a list, which is number one, you have to pass in your image to the model to detect fracture. So here the type is image and you are passing the decoded image. Do not pass the encoded image here because the encoder is a string for Firebase. So for here, we will just pass in the original image and let the model to do encoding itself. Besides the image, you are also passing your question, which we will declare as prompt in this case. Okay, so now we know that what is encoding and what is chat template. Let's go back and look a bit on the class MLM that we run previously. So here we are loading the model, self.model. And as I mentioned, we are actually loading a model, a Q1 model. So if you are interested in what medical specific LM we are running, you can read the documentation. So yeah, we are running a medical specific MLM, which is 7B, and it's called Lingshu. So even though it's 7B is considered a small LM, but it's actually still a bit large when you wanted to load into your notebook. So that's why we are running a code to quantize the model. Yeah. Here we are using bits and byte config to load the model in 4 bits. So one is quantization is that if you guys know, actually LM is kind of like essentially a neural network, and neural network is also it's just a network with many nodes, and each node is just like a decimal or a floating number. So if each node is a floating number with, let's say, 10 decimal point, each of the nodes actually holds some of the memory, and that's why your model is huge. But now instead of like having 10 decimal place, I want to round out into just 4 decimal place. So that is what this load in 4-bit does. So it actually forces all the nodes to be stored in only 4 bits, which makes your model smaller and can be loaded efficiently into your notebook. This is what you do if you have very limited hardware specification. So in this case, we're only using Colab with T4. That's why we have to make the model a little bit smaller. But as a trade-off, if you quantize your model, which means you're making your model smaller, this will also affect your accuracy. So your model accuracy after quantizing will be decreased. And also here we are also loading the processor for your model, which is Q1. So actually each different models, like from different company like Q1 or Gemini, they actually use different processor. But what's good from Hugging Face is that they have this auto processor, which is a unified interface, and it will actually detect which processor you use based on the model ID and configuration that you provided. So now we have the quantized model and also the processor. Then we are ready to run our model. So here we have another function. It's called analyze. You will use this method whenever you wanted to ask or pass any input to the model. So here, as I mentioned, we are passing in using the chat format with user role, your image, and the prompt. And here we are also applying the chat template and also process the vision info, which is some code that to pre-process your input before passing into the model. So actually the encoding for the model happens in this chunk. Then later you will pass in whatever input you have processed into your model. So here's two very common parameter that we believe you guys should have known. Number one is called temperature. Actually, temperature is to define how creative your model should be when you are generating your output. So the higher your temperature is, the more creative and more more variance your model output would be. But in this case, we are actually handling X-ray or medical cases. We wanted to be more cautious. That's why we are setting it to a lower temperature so that your output is actually quite constant even though you are asking the repeating question. So if your case is if you are building an agent in a higher state like medical or like in finance area, you are encouraged to set to a lower temperature. But let's say if you are using a model to create stories or to make reels or anything, you can set it to a higher temperature. And another thing is the max new token, which actually defines how long is the model output would be. So here we are setting to a standard of 512 token. So just curious, have everyone finished loading your model? Is there a green tick next to your model equals to MLM code? Yep. Okay. Finish loading the model? Okay. So maybe let's jump back to check to see the load encoding function. So here you can run. Remember to replace the placeholder, and otherwise you won't be able to run it properly. So here let's declare the function of encoding and decoding, and let's run it into a new. I'm using a sample image. So as you can see, after I run the function base64 image encode, your image will now be converted into just a sequence of characters, which we don't know, but it's good to save in your Firebase. You can also convert your encoded image back to an actual image by using the decoding method. So this is our original image. Okay, so let's move back to understanding the MLM. So after you have made your chat template and also pass it into the model to generate the output, you would receive an output with several elements. So let's take a look at each of the elements that the MLM returns to you. Number one is that it will actually return something with the key B box 2D, which is a bounding box. So these are actually the coordinates of the detected fracture in the image. And since the model only returns the coordinate of the fracture position, we will need to use this coordinate to draw back the bounding boxes on top of our original image just now. So in simple words, your model won't return the processed image directly back to you. You still have to process the image a little bit before seeing like the label area. And also it will return the issue of your bone fracture, which is fracture. And lastly, it will return like a human readable output explaining on what is the fractures in the image. So here, let's see how can we actually process the output from the model to draw the bounding box on top of your original image. Here we are actually using reged, which is regular expression in full sense, to process your model output. So here we try to find the open and close bracket because the model output will look somehow like a dictionary. So once we have matched, we confirm that the model output is not corrupted. We can then convert it into a dictionary by using the diction.load function. And then we will find the bounding box key inside your dictionary to retrieve the coordinates. So the coordinates here will be a list of 4 numbers. So the first two is x min and y min, which is your top left corner of the bounding box. And the second two, the last two is actually x max and y max, which is your bottom right corner point. So every time you ask the model will return the top left and bottom right corner, and you will draw a box based on these two coordinates. So back to the process and draw function. If you found that the bounding box key is actually in your dictionary, you extract it and you will draw the bounding box using a function called draw bbox on image. And then besides the bounding box, we also need to retrieve the report, which is a human readable explanation from the model output. So here we are trying to retrieve it using the dot start and dot end function. So worst case, if your model actually doesn't really return a proper explanation, you can also fall back into just getting the label. So even though the model doesn't actually explain, it should also return like the diagnosis, if fractures or normal. So we'll just retrieve the label in case there's no detailed report. So here, if you go back to your Google Colab notebook, let's try to replace some of the placeholder. So in your process and draw function, you can replace this placeholder into the key, which is vbox2d. And if there is this key, you can also retrieve it to get the coordinate of the bounding box. Do not run this chunk of code yet, because the drawn bbox on image function will only be used when we build the front end using Gradual later. Okay, so now we have the coordinate, and how do we draw it onto our image is using this draw bbox and image function. And there is one very important note that I would like everyone to take note of, is that your model actually doesn't know the image size. It doesn't know the actual size, like how long is what is the width or height of your image, because every time your model will just pretend that it's actually a rectangle image with 1000 unit wide and 1000 unit tall. So which means the processor just now in the MLM class method, it will actually crop your image and normalize it into an image with 1000 unit wide and 1000 unit tall. But that is not the case for your original image. So that's why we need to retrieve the correct coordinate by applying a little bit of math, which is to divide 1000 from your xmin, xmat, ymin, and ymax, since again it's normalized into an image of 1000 unit, and then you multiply it with the original width and height of your image. So in this function, which is the drawable on image again, you will replace all placeholder into 1000. And do take note that you have to place this dot zero, not just put 1000, but 1000.0 to indicate that this is actually a decimal number, a floating number. If you put like this, your left value would be integer only, which will be a little bit inaccurate. In this case, we want it to be we want to keep the decimal point after the division. That's why everything must be 1000.0. So now we have gained the correct coordinate to be plotted on your image, which is left, right, top, and bottom. Now we will draw the rectangle in red using this 4 coordinate value. And we set the line with the line to be 5. If you want like a more thicker box, you can also adjust the width, but currently we are setting it to 5. And lastly, we will return the annotated with image, which is the image with the drawn bounding boxes, back to the front end later. Yeah, so this is the bounding box that we are drawing later. So obviously you can see that the fracture is happening here, which means that our model is actually doing a good job. It's predicting the fracture position correctly. So far, any question? If no question, then we'll take a break and we will continue in, I think, 15 minutes. Hi everyone, so we are starting back and now we are trying to integrate Firebase, which is your context for the chatbot and also the front-end interface. So this tool might be more useful for you in the hackathon because some of our problem statement requires you to have a database to track your history. So yeah, let's continue with the part 2. And also this is our R&D member Omar. So he is the speaker for our session 2.
Okay. Hello, everyone. We have seen in part 1 of the workshop how to download the MLLM, how to quantize it, but we need a way to store our memory or chat history, which will be beneficial for your hackathon because you'll need to build a memory for your system. To integrate our memory, we will use Firebase, a new NoSQL database from Google. What is a NoSQL compared with the relational database that we know? NoSQL using documents the same way as our Python dictionaries. But for relational database, they use columns and rows. As I said, instead of using the relational database, which is rows and columns, we use a document database or NoSQL, which simulate how the AI that use this type of databases, such as ChatGPT, Cloud, or even Quinn and other LLMs. We will start by configuring our NoSQL database from Firebase from Google. You can go to this link, which will open this page, which is called the Firebase. Later, you go to console and create a new database object. Name it anything you want. Here, I will name it MLLM. Continue. Disable the Google Analytics and create the project. You can see now it's ready. You go. Disable it. Now, you need to go to database and storage, Firestore. Create database. Next. Next. Choose start in a test mode. Test mode allows a connection from outside your can say system, but for the production. For the other one, you need to configure other things to start using it. Yeah. Now we have our database ready, but we need a way. If we went here again, we need a way to connect to the database from our Colab to the Firebase or Firestore. So we need our credentials, but we will not use an username and password. We will use a JSON file that contains our credentials as a certificate. We are using what's called credential.certificate, and we need to download this file from our Firestore by going to settings, service accounts, and generate new private key. You can download the file, as you can see. Now we go back. We need to upload the file to our Colab. You go to the files and upload. and we select our file. Okay. Yeah. Now we can see that our JSON file is now loaded to our Colab. Now we need to be careful. For each user, there is a different file that you need to change the name. For me, it's named MLLM and the other string for it. This will create our client for the database, and we run it. We'll wait for the Colab to finish running. After we connect, we will start with our after we connect, we'll start with creating our functions that will help us to interact with the front end and the back end. Because now, after you call the model, you need a way to show its output to the front end. To the front end. We'll start with the user ID. This could be unique, but for us, we are using AIC participant. Okay, the first function we have, which is create session. This will initialize a new diagnostic session for our MLLM, for our interface. By the way, to show you a scratch of our interface, how it will be, this is a simple UI that we are using with the Gradio. Later for the hackathon, you may use different libraries, or maybe Streamlit, or even using your own programming language, JavaScript, or anything you want. We'll create a consultation sidebar and a place to import or upload our image, and a chatbot panel, and an input field to ask a continuous question or a follow-up question. Okay, you go to Fire. Yeah. Okay, you go Firebase. Go to console. Have you here? Then you go to create new Firebase project. You name it the name you want. I'll use one. It's ready. Then you, for the credential, you go from settings, service account, and you generate new private key. Okay, for our helper function for our backend, which is create session, this will create a new diagnostic session for our MLLM and its memory. It uses a DB, which is for database, our database, collection, which is like a table. We are storing our memory in it. For us, it's named session. You may name it anything later, but now it's configured as session. .document to get the document itself. Remember to change the placeholder for your notebook. Then we are using the session.set. This will create new field inside our database that has these IDs, which is our keys, user ID, creation time, and history as an empty list to store our interactions later. And it returns the session ID. After that, we need a way to save to our database. We have initialized our database, our creation, but we need a way to initialize or save our interactions. So the add initial scan will update our history, which has been configured previously, to include the timestamps, the image base, 64, and the report, and the bounding box that was generated by the LLM. After that, we need also a way to store our follow-up questions. by using add follow-up question helper function, it updates also the history, but now we are also including our question and the answer from the MLLM. We are using array union to update so we do not overwrite our history, because if we just use set, it will overwrite our previous history we have included or ask our model. Later, we have the get session history. As we have discussed previously, our LLM is stateless, which means after you just use the API for the first time, it will forget what you have asked even 1 second ago. So we need a way to fetch our memory or interactions, pass it into the model, and then the model will try to figure out what have been discussed previously. This will be helpful for your hackathon later when you want to include a memory. Because without memory, after you ask maybe what's that, it will not be able to answer the question. Also, we are using only the last 5 interactions to save the context window. Try to remember to change it in your notebook. Moreover, we need a way to fetch these data. How? We will load the user sessions. It creates a session list to fetch the data from our database. First, it will take every document we have in our backend and get the creation time. The creation time then will be used as a label to uniquely identify our session. Maybe you can later as a customer ID or based on the problem you have. If in case we don't have our creation time due to an error, we are using the session ID as a label. Then we append to our list. We have label and doc.id. For our UI, we need a way to pass the session ID or the document ID, and to pass also a human readable string to be able to understand. It will be something like that, to be able to navigate between your session as the one you are using in ChatGPT or Gemini. It will be, or else it will be hard to really navigate between your session or messages. Then we sort our list based on the most recent message by using the reverse true and the key, which is get session label, which is configured previously to get the first item. Moving forward, we have the switch session. We need a way to configure our backend to allow us to switch between sessions, as we use in ChatGPT Gemini. For each session, the model can remember we have asked between the session itself. So from our session, we will try to find the image. So it must be passed to the LLM to diagnose it by decoding the base64 image back into an image, because it's required by the Quinn model. Moreover, we need to get the bounding boxes to be drawn as a layout or a layover our image. Then we call our draw bounding box function. This can be used in your hackathon maybe as a helper function to maybe filter based on the user, maybe based on how is it related to your user maybe. Then we fetch the report and we use the chat.ml template as discussed previously. We are fairing the role user and the assistant by taking the entry and taking the report as a key and the follow-up question and append it to our UI history to be shown in the front end. Then we need a function to allow us to start a new case by clearing our front end, which is the start new case. Then run initial scan. This is the first time when you run the front end, it will run this function. It will call the model to analyze our image and to produce the report, bounding box, and the answer to the user, which is the report. It will be configured based on active label, which is our session. For each session or chat history, we have a special ID to uniquely identify it. Then we have the run follow-up question. This is in our input field. We can enter a question, hit enter. The model will take our previous messages, try to understand it, and produce the report or the answer. It will take and append the message from the user, and then call the format chat history, then produce the new image, which is process and draw, and then append to the UI and show to the UI. Any question for that? Now we have built our backend to be able to interact with database and the front end. Now we need to build the UI itself. First, we customize our theme. We are using a primary hue of indigo and blue, slate, and small spacing size and radius of large. We are using radio. Maybe later you can use different frameworks, maybe Streamlit. We are creating a panel or a workspace the same as this way. The gr.blocks will create our workspace so we can customize it based on our preference. We have a state to help our browser keep track of our session. Then we split based on row and column. Now we will try to split by row and column because we have the sidebar, we have the image, and the chatbot area. Okay, we add the button, which is a new chat button, and we try to find the initial choices from our database and add a radio button so we can select. Later, we have the place to upload our image and the chatbot area. Here we are defining our input image and the chatbot area. You can see its messages. This tells Radio to treat it as the messages we use in ChatGPT. And we have a field to input our follow-up question, which is chat input.submit, will be called later. It has a placeholder for ask a follow-up question and a send button. Any question? Yeah, you need to replace the placeholder or it will not work. Yeah. Finally, we need a way to fire our functions. We have session selector change. You need to change the placeholder in your notebook. For switch, it will call the switch session function. The new chat will call our start new case. For our scan button, it will run the initial scan. And for the chat input and send input, they are calling the same function, but with different in different way. If you hit enter, you will use the submit. If you are clicking, you will use the send button. Then after running, you will get the interface to interact with. Something like that. Any question? Now we can test our UI and backend. We have several images. I'll try to use this. A run diagnostic scan. It will call our model to analyze it. And it will draw the bounding box and show generating the generated report. Then we can ask a follow-up question, maybe give me more. You can see the model will generate the report. Any question? Get session history. Yeah, this one. Yeah, the placeholder with negative last n column. Hmm? Yeah. Yeah, you can also deploy it online. They have their a way to deploy with the hosting GPU upgrades. Yeah, maybe you can use it later for the hackathon instead of building using JavaScript or React or etc. Any question? For the context. Mhm. User. Good. Percent of- Any question? I think it's okay. So yeah, maybe you will need this for your hackathon. You will need a session. You need a memory. Maybe you will use different type of NoSQL database, MongoDB, maybe Firebase if you want to keep it online. I'll try to see. Okay. And the initial scan. Yeah, you actually can find everything in the Notion. just final takeaways. Yeah, final technical consideration you need to consider when using quantization, that for sensitive tasks, you may not use that aggressive quantization in F4. Maybe you'll go for 16 or something similar, because maybe the model will start to behave in a not expected behavior, I would say. One of the techniques you can use is reducing the temperature 0.1 or even 0.01 to make it more predictable. And based on the problem itself, you may choose the model, because sometimes domain specific, they are trained on vehicles, animals, text from online. But for the specific or domain specific models, you will need specific data that will be trained on. Any question? If everything is okay, then we can end here. Add initial scan. Encoded image. Base 64 underscore image shows. Yeah, then, but have you configured your Firebase?
Yeah, I poked into the.
Yeah. You want? Okay.
Yeah, I think.
Yeah. Okay. And we can end here.
So that's all for the hands-on session. So as you can see, it's not really that complicated if you are going to build an agentic system in your hackathon. Just curious, who is involved, who participate in the hackathon here? Anyone? Your team? Okay, so we have a few team. Yeah, so you guys can also consider building a gradual interface. If you're not really familiar with like a full stack development, you can try gradual, and we will release the full Google Colab notebook, which is the one without placeholders, soon. And if you guys have any questions regarding to Chutes or this workshop, you can also raise the concern in either WhatsApp group or Discord, because we are all in there. Yep, and that's it for our workshop tonight.